Good day, wizards. Welcome to your lesson for grade 12. We are working with term 2, and as you know, term 2 is a continuation of trigonometry. What is trigonometry? Trigonometry is a branch of mathematics that use trig identities. We work with a few of them, such as sine, cosine, and tangent. Those three have reciprocal angles. We work with the reciprocal angles as well. What were they? They were cot, sec, and cosec. We learned them as reciprocal angles. What else did we learn in trigonometry? Over the past term, we have learned double angle identities. We also learned compound angle identities. We also learned a few tricks and trades when working with trigonometry. What is the biggest rule that we learnt, or the broadest understanding of trigonometry? We learnt a phrase, as you can see, that is called SOHCAHTOA. SOHCAHTOA is the basis of trigonometry. What that represents is sine, cos, and tan, and the SOHCAHTOA part indicates your opposites, your adjacents, and your hypotenuse. For example, sine is your opposite over hypotenuse, cos is your adjacent over hypotenuse, and tan is your opposite over adjacent. Remember, if you wanted to change those two reciprocal angles, you would swap the identities. You would swap O over H, A over H, and O over A. Those will give you your reciprocal angles. So that was the broadest definition of trigonometry that we have come across. That helped us when we worked with right angle triangles. So wizards, it's very important for us to understand that trigonometry cannot work for all triangles. When we use SOHCAHTOA, they are restricted to right angle triangles. What do right angle triangles mean? Right angle triangles mean that they have a 90-degree angle. And with all 90-degree angle triangles, we can also use theorem of Pythagoras to help us. That's just for you to understand that you don't only have to use trigonometry when working with examples. Remember that there are other tricks and trades that you can use to make your calculations easy. Let's have a look at some of the aspects of trigonometry that refer to compound angles. Remember that these are compound angle identities, and you may have to look at how you derive them. Remember that in your examination, not all derivatives will come into play, but you do have to know some of them. Let's have a look at some of the compound angle identities. Some of the identities, for example, the addition formula. The addition formula will speak about cos, alpha and beta, or A and B. You can add them, and the next one shows you how you subtract them. So you have your cos of A plus B, but you also have cos of A minus B. What is the only difference when you work with addition and subtraction? When you look at cos A plus B, we get cos A cos B minus sin A sin B. So can you see how addition and subtraction work inversely? When we work with cos A minus B, I should have an addition. So I should end up with cos A cos B plus sin A sin B. Let's have a look at how we work with sine. Sine also has the addition of A and B as well as cos A minus B. So can you see how when we work with sine, cos A minus B can also be used in terms of sine? Let's have a look. We have A plus B, so sine of A plus B will simply be sin A cos A plus cos A sin B. So all we are doing is making sure we use both A and B twice on each side. Let's look at cos A minus B. We want to use sine. Do you remember in the upper example, we only used cos? So in the next example, we want to introduce some sine. For example, sin A cos B minus cos A sin B. So wizards, can you see how we work with that addition formula? The next thing we look at is examples. We look at examples using compound angle formulas such as sine x plus 30 degrees. Sine x plus 30 degrees, we can use the formula that we just learnt with addition. That would give us sine x cos 30 plus cos x sine 30. When you look at your special angles or your special triangles, you know that we end up with cos of 30 being the square root of 3, then your sine x plus cos x all over 2. Now wizards, we need to look at examples on our own. Let's try to do the following example together to make sure that we understand what is happening. In this example, we're going to use a proof. So let's go ahead and try that example.
In order to prove what sine of 75 degrees is equal to the square root of 2 into the square root of 3 plus 1 all divided by 4 is without the use of a calculator. What is the first step we need to take? The first thing we need to do is to consider the given identity. So your step 1 is to look at the identity. When we look at the identity, we know that we have special angles. Special angles for 30 degrees, for 45 degrees, for 60 degrees. What do we know about the number 75? If we were to write the sine of 75 as an angle of 30, 45 or 60, I can say that that is equal to sine of 30 degrees plus 45 degrees. That would give me 75. We can therefore use the compound angle formula that we just learned. Using the compound angle formula, we are going to use sine into a plus b. And what does that identity express? We can use that in terms of our trigonometric function values. So your step 2 when working with proofs is we want to prove the left hand side and we want to prove the right hand side. So what do? Let's work with the left hand side. We can say that the left hand side is equal to sine of 75 degrees. Using what we know, we can say sine of 45 degrees plus 30 degrees. That's going to be equal to the compound angle formula, which gives us sine A, which is 45 degrees, cos B, which is 30 degrees, plus cos A, which is 45 degrees, sine B, which is 30 degrees. Let's go ahead and calculate that. What is the trigonometric special angle for 45? The special angle for 45 degrees gives me 1 over the square root of 2. Now wizards, you cannot use the calculator. If you use the calculator, this will give you a simplified version and it would give you square root 2 at the top and not at the bottom. So you will end up with square root 2 over 2 and that answer is completely wrong. So sine of 45 degrees is 1 over square root 2 multiplied by cos of 30 and cos of 30 is square root 3 all over 2 plus cos of 45 degrees, which is 1 over square root 2 times cos sine of 30 degrees. Why sine of 30 degrees? That is simply half. So what am I left with? I am left with 1 times square root 3, which is square root 3 all over 2 square root 2 plus 1 times 1 is 1 all over 2 square root 2. Can you see that my numerator is different, but my denominators are the same? Because my denominators are the same, I can say that this is equal to the square root of 3 plus 1 all over 2 square root 2. Why can I say that, Wizards? I can say that because what I've worked with is the same denominator. Then what I want to do is I want to multiply to remove the square root at the denominator. If I multiply this by square root 2 over square root 2, what am I left with? I am left with square root 2 into square root 3 plus 1 all over 2, and square root 2 times square root 2 is simply 2, and 2 times 2 gives me 4. What have I done? If I look at the answer that I am left with, it is equal to the answer that I'm asked to prove. So I can then say that the left-hand side is equal to the right-hand side. So what I've effectively done is I have taken my proof of 75 degrees, split it up into the special angles. Once I've split it up into the special angles, I've used my compound angle identity for sine A plus B, and then I've done my calculation so that the left-hand side equals the right-hand side.
So Wizards, we learned our proof. We learned how to prove sine of 75 degrees. We learned how to prove that by using a right-hand side and a left-hand side. When we worked through the example, we learned that we can change both sides as long as the routine is kept the same. We learned how to do this proof using our compound angle identities. Now, Wizards, trigonometry is really hard. It is one of the hardest branches of mathematics that you will come across. It's not easy for you to understand trigonometry without practicing a few examples. Those practiced examples require repetition and multiple examples. So let's go ahead and go to the iWiz website. The iWiz website has worksheets that you can use and you can learn from. Those worksheets will help you understand trigonometry, but also improve the required knowledge from one example to the next. So if you have trouble with it, you can always come back and watch these videos again.
We need to learn to live with the COVID virus, you know, the new normal, at least for the next few months. And we have just what you need to make sure you never miss a single school lesson. And it's absolutely free, mahala! High quality, powerful, animated lessons for all your subjects. So don't spend a cent until you have tried iWiz. It's everything you need. All video lessons, textbooks, workbooks, exam prep. We want you to ace 2021.